Good day, everyone. We are honored to present our research title comparing the effectiveness of gamified learning and lecture-based learning enhancing science exam scores among senior high school STEM students. Learning is very important in our daily lives, and the way students learn affects how well they understand and remember lessons. In many schools, LPL is still the most common method, and it's when teachers explain the lessons while students listen and take down notes. This works for some students, but others find it boring or hard to focus on, especially when the topic is difficult. This method may not also account for the individual's capacities of students. On the other hand, GL is becoming more popular, especially in the pandemic. It adds game-like elements such as points, rewards, and levels to make learning more interactive and fun. Some teachers now use online tools like Kahoot or quizzes or even classroom games to boost participation and improve scores. Science exam scores are important because they reflect how much students really understand. Exams are still one of the most accurate ways to measure knowledge. However, studies say LBL often lead to lower scores, while interactive strategies like GL help boost performance, while some say that this method don't really have a direct effect on exams. With these two different learning styles, we became curious. Which one helps students learn better, especially in science? And more importantly, what do students think? That's why our study focuses on how STEM senior high school students perceive GL compared to traditional LBL when it comes to improving their performance in science exams.
Thank you, Avi. As said, recent studies showed that GL with points, rewards, and levels can boost engagement. Like for an example, Tiria and Cabales found that it improved test scores, but Alasadon et al. Said performance gains were not always significant. LBL, though still common, tends to cause passive learning, and Liu et al. Found that this weakens retention. During online classes, Wester et al. Saw that science scores drop when lectures were the main method. However, most of these studies were done abroad, focused only on outcomes, not perceptions, and used general student samples. That's our research gap. There's empirical and population gap and limited perception-based research comparing these two methods among STEM senior high school students. To address this, we asked, first, what gamified learning factors do STEM students find the most helpful? And second, how do they compare gamified and lecture-based learning in science?
To answer these, the study will use mixed methods design. We will work with 60 grade 11 STEM students from De La Salle University Integrated School, selected through purposive sampling. Participants must be currently enrolled in a relevant science subject and must have received a bronze medallion for academic excellence in the previous term. These criteria ensure a fair and reliable comparison among students. An invitation email will be sent via the school's mailing system, containing the study overview, eligibility criteria, and links to the digital informed consent form. Students who meet the criteria and complete the form will participate in the 5-point Likert scale survey, which will assess the impact of different gamified learning components on their learning experience. And to gather qualitative data, we will invite 30 students to participate in semi-structured interviews. A sign-up form will be sent via email and shared on social media. Once the target number is reached, confirmation emails and interview schedules will be sent. The interviews will be held over Zoom, and while the questions are prepared in advance, they will be given on the spot to ensure authentic responses. Interviews will then be audio-recorded with consent and transcribed verbatim. For the analysis, survey results will be examined using SPSS to calculate descriptive statistics, like the mean and standard deviation, and determine which gamified elements students perceive as most impactful. For the interview data, we will apply Brian Gallagher's thematic analysis using Microsoft Excel. Codes will be generated inductively, and responses will be sorted using color coding. Triangulation and iterative analysis will help us refine the themes and identify key insights. To ensure trustworthiness, we will follow Guba and Lincoln's criteria, including credibility through member checking, transferability via detailed context, and dependability and confirmability through an audit trail. Finally, all ethical guidelines will be followed. Participation is voluntary, consent will be obtained, privacy will be protected, and data will be stored securely with no identifying information used in the final report.
So with that, we've we've covered all three parts of our research: the background, the significance and the gap, and the method. So here are our appendices. So we included the consent form, a sample of our Likert scale survey, and the interview questions. And also the AI tools we use like SciSpace and plagiarism checkers. And here are our references. All sources are properly cited following APA 7 format. And that concludes our presentation. Thank you for listening, and we hope you have a great day ahead.